All right, 3-4 notes. We are going to go through and classify triangles and talk about the angle and their side relationships. So if we're classifying by angle size, I know you guys have seen these words before, right? Obtuse triangle, right triangle, acute triangle. Let's just make sure that we have a definite definition. So an obtuse triangle is a triangle in which one angle is obtuse. Don't forget, obtuse means somewhere between 90 degrees and 180 degrees. So if X were our angle, we're talking about one angle is obtuse. Now, hopefully that makes logical sense. Think about two angles. Could you ever have two obtuse triangles or two obtuse angles in a triangle? Well, if I just add like 91 and 91, isn't that already over 180? Okay, so that's why it has to be one. Likewise, in a right triangle, again, it is one angle for the same reason as the last one that we just talked about. So only one angle is a right angle. Only one angle is a right angle. And right angles are equal to exactly 90 degrees. Okay, and then an acute triangle, this one changes. In an acute triangle, all angles are acute. And remember, acute means that your angles are somewhere between 0 and 90 degrees. Okay. All right, so let's say if we were given these three triangles and the directions just said, you know, classify them. In other words, tell me what they are, obtuse, right, or acute. Well, the first thing I should see for work in your picture is anytime you're given 2 out of 3 angles in a triangle, I hope your first instinct is to either get on your calculator or the side of your scratch paper, whatever, and find that other angle, okay? So here I've got 40 plus 80, and I know that a triangle, those 3 angles add up to 180. So if I do 40 plus 80 to get 120, and then subtract that from 180, you should agree that this angle is 60 degrees. All right, let's analyze. All of those angles are less than 90, so they're all acute, which means this is an acute triangle. Okay, there's how you would show the work. That's the minimum amount of work you can have. The next one, again, 2 out of 3 angles I have, I should find the other one. 40 and 50 add to 90. 180 minus 90 will give you 90. And I know 90, I should be putting that box in the corner. And hopefully you're now going to tell me that's a right triangle because you've got one right angle. All right, the next one, 30 and 20 is 50. 180 minus 50 gives you 130. 130 is an obtuse angle, and therefore this is what's called an obtuse triangle. Again, remember, look at these pictures. Okay, they almost all look exactly the same. Remember, we don't trust what the picture looks like. We trust the information that's given to us. Okay, we got to keep emphasizing that. All right, so that's based on angle size. Now if we base it more on sides and kind of equal parts, if you will, then here we go. We've got 3 more words to think about. So a scalene triangle is a triangle in which no 2 sides are congruent. And what does congruent mean again? Remember, congruent means equal. Okay, so a triangle in which no 2 sides are equal. All right, so if I was just drawing an example for you. So an example would be, you can come up with anything on your own. However, we do have to think about one thing. So let's say I have sides of 50, 54, and 60. So if you're coming up with one on your own, it's okay, but I'm going to make it relate back to what we've done in this chapter. Do my sides of 50, 54, and 60 make a triangle in the first place? And that's good review to keep up on that. You should be thinking, any two sides of a triangle have to add to be greater than the third, the bigger one. The two smaller sides have to add to be greater. So real quickly, if I was just asking you, I'll erase this since it's not technically what we're doing here. But real quickly, do the smaller sides, 50 and 54, add to be greater than 60. And you could tell me that 104 is greater than 60. And yes, those side lengths do make a triangle. Okay? That's the triangle inequality from a previous section. Right? So now, in an isosceles triangle, you need to know that at least two sides, it's typically two, but at least two sides are congruent. Or equal. Okay, we'll practice that same thing again. So I'll give you an example. For an isosceles triangle, I just need two sides to match. I'll make both of these 6 and this one 10. Now I thought about that as I was making it up. Does that make a triangle? Do the two smaller sides add to be greater than the third? Yeah, 6 plus 6 is greater than 10. 12 is greater than 10. Those would make up a triangle, just to get you a little bit faster at that. Okay, so there is an example of an isosceles triangle. And then next, let's go with equilateral triangle. In an equa, just like the word says, equa for equal. In an equilateral triangle, all sides are congruent. All sides are congruent or equal. Okay, so for example, I could just have all the lengths be 10. 10, 10, 10. Again, if you're analyzing, does that make up a triangle? Well, the two smaller sides are supposed to add to be greater than the third, so you could be writing 10 plus 10 is greater than 10. And yes, 20 is greater than 10. So those do make up the sides of a triangle. Okay. All right, so we're ready down here. We're going to have to do some analyzing and some logical thinking here. So first things first, I hope the first thing you're going to do is tell me that this other angle, 100 plus 40 is 140, so 180 minus that will give me 40 degrees. Okay, so based on angles, that's the stuff from the first screen, I hope you're going to tell me that this is an obtuse triangle, right? Because 100 degrees is obtuse. Based on sides, well, you got to do some inferring here. So notice, guys, if you have two angles that are equal, that means that the sides across from them are also equal. So I'm going to mark them equal, okay, like we've practiced our marking. Well, if I have 2 out of 3 sides equal from above, that is also called an isosceles triangle. So you need to classify it in as many ways as possible. Okay, like it says. All right, next problem. If I take the 30 and 60 and add it to get 90, 180 minus 90 gives me 90 left for this also. So based on angles alone, this would be a right triangle. Okay, from the stuff earlier. And now, coming up with some stuff logically, we need to understand that if all the angles are different, right? The 60, the 30, and 90 are all different, then the side lengths across from them should all be different. You don't know what they are specifically, but you know they're all different. And that is exactly the the definition of scaling. No two sides are congruent. Okay, so based on the side lengths, what you had to infer from the picture, This is also scalene. Okay. And last but not least, okay, this one with 3 sides. So first of all, based on sides, since they're given to us, 5, 7, and 8, none of them are the same, and therefore it is scalene. Now, you might be trying to do the same thing we did in the last one and make some inferences. Well, I guarantee that I agree with you if you're going to tell me 5, 7, and 8 are all different, and that should mean that the angle across from 5 and the one across from 7 and the one across from 8 are all different, but we don't have a definition for all different angles. Just because they're different doesn't mean one of them isn't a right angle. It doesn't mean one of them isn't an obtuse angle. It doesn't mean that they're not all 3 acute. So when we give you sides, you're only going to be able to answer me about sides typically, okay, and not about a name based on angles, okay? All right, so that would be scalene. All right, so now we've kind of started this a little bit, but let's talk about our angle-side relationships. Okay, talk about our angle-side relationships. So first things first, when you see a triangle, the angles, right, at the vertex, right, there's angle A, they're always labeled with capital letters. So that's the first thing to notice. Okay, so let's put that down here. Angles are labeled with capital letters. And sides are related to them, but they are going to be lowercase letters. So in other words, by that I mean the following, and then I'll do some erasing again. So if I go across from angle A, that side that's across from it is lowercase side A. Likewise, if I go across from angle B, the side across from it is lowercase side B. If I have angle C, then the side across from it is lowercase side C. And I know sometimes it's hard to tell a difference between the uppercase and lowercase c, but I'll definitely be able to tell the difference between your A's and your B's. Keep this in mind, guys. This is super important for labeling, all right, for the rest of the year. So we've said angles are labeled with capital letters and sides are labeled with lowercase letters. Okay, so now I need to clean up my picture a little bit so that I don't have all of that going on in there to confuse you. So let's go ahead and get rid of all of this and just leave our labels as they were. Okay, perfect. So now let's go back to solving the other angle. All right, so 70 and 40 is 110. 180 minus 110 would give me that this angle is also 70 degrees. Okay, so you need to recognize our relationship, which says that 1, the longest side, is across from the largest angle. And likewise, the shortest side is across from the smallest angle. And then the medium length side is across from the medium measure angle, if you will. Okay. Now in this specific picture, guys, what you need to recognize is that if I were to ask you the smallest angle, okay, definitely you would be telling me angle A because 40 is smaller than 70. If I asked you what's the largest angle, just for practice, well, there's two of them that are 70. So you would just tell me they're equal. You would tell me angle B equals angle C. Okay, if I was asking you for the largest angle. And now let's reverse that because of our relationship and what we're asking you about angles and sides. So now what if I ask you for sides? Well, if I ask you for the shortest side, I hope you're going to tell me, oh, the shortest side is across from the smallest angle. So since 40 is the smallest angle, then side lowercase a is the shortest side. Okay. I'll get rid of that to not confuse your picture again. And now once again, what if I asked you, what's the largest side? Well, once again, you should be telling me, I know the largest side is across from the largest angle. I have two of them, okay, that are the largest. And so I know that the sides across from them, lowercase side B, is going to equal lowercase side C. So in fact, in the picture, I'm going to go ahead and mark them equal. Okay. All right, that's just a little practice with that relationship so that you can get that down. And understand that for future worksheets. Okay, so lots of important things going on here. I know the notes are kind of short, but lots of important things. So really go back and review those.